What's up, everybody? Welcome back to Math Time. Today we're going to be talking about how to add and subtract rational expressions. Okay? I know I use the word functions in the learning target, but really it's not functions we're adding and subtracting, it's just expressions. Okay? So we have a guest co-star today. We have the one, the only, Camille Netherland. Okay? And she's here to talk to you guys at the intro of the problem about how to add fractions. Okay? So she's very good at it. She's very gifted for an 8-month-old. 8-month-old, I can't talk. Alright, but what we're going to do first is we're just going to look at adding a couple of fractions, okay? So we're going to talk about adding 1/2 and 2/3. Now, in order to add fractions, and this is going to be the same important part to add rational expressions, is you have to have a common denominator. So what you want to do is you want to look at the factors of each denominator right now. The 1/2, the denominator has a factor of 2, and the 2/3, that has a factor of 3. We need both of these guys to have the same set of factors. Okay? So we realize the 1/2, the denominator is missing a factor of 3, so I'm going to multiply the 1/2 by 3/3. And the 2/3, that's missing a factor of 2, so we're going to multiply the 2/3 by 2/2. Now, you'll see I already made a mistake here. And so let's go ahead and fix that little error. That should be 4, which is going to change that to being 7. Alright? So why am I allowed to multiply by 3/3? Like, why am I allowed to do this? Well, multiplying by 3/3, what am I really multiplying by when I multiply by 3/3? Camille, what do you think? It's 1. Very good. She says 3/3 is really just the number 1. And does multiplying by 1 change anything? Does anything happen when I multiply by 1? Am I changing the value when I multiply by 1? No. So I can multiply by 1 in any way, shape, or form I want. It just so happens that 3/3 is going to allow me to adjust to having the common denominator. So I do 3 times 1, which is 3, 3 times 2, which is 6, 2 times 2, which is 4, 3 times 2, which is 6. Now that I have a common denominator, I can just add their numerators and keep that common denominator. So 3 plus 4, that's 7. And then we maintain that common denominator of 6. Alright, and that is really the idea that we're going to carry on to in doing each one of these problems. Okay, let's go to the next problem. So my co-star had to go to bed. Alright, sadly that has the limitations of an 8-month-old. But let's go ahead and dive into this problem. I'm actually going to go through this problem pretty quickly. So what you should already notice in this problem is that they have the same denominator. And since they have the same denominator, that means I can put the numerators all together over one big denominator. Alright, so we get 6 plus x plus 2 over x minus 5. 6 plus 2 is 8. So we get x plus 8, x plus 8 over x minus 5. Alright? And we're done. Because there's nothing left to do in that problem. Alright, so let's go to our next problem. Okay. In this problem, you see that once again, we already have the same denominator. That means I can make this one big fraction over the same denominator. And then I can just put both numerators down here. So I'll get x squared plus 3x minus 2 plus 4x, plus 12. Okay? And then I can just put like terms together. So I'd get x squared plus 7x plus 10. Because negative 2, positive 12, that makes 10. And 3x and 4x, that makes 7x. Over x plus 5 times x minus 2. Alright? And now what you should notice is that I could actually factor this piece right here. I'm going to have to write over to the left side. And if I factor that, I would get x plus 5 times x plus 2 over x plus 5 times x minus 2. And so then that means I can cancel out my x plus 5s, and I'm left with x plus 2 over x minus 2. Alright, and that would be my answer, x plus 2 over x minus 2. Alright, let's go on. Actually, we're going to skip a few problems here just for the sake of not making this a video that lasts, 18 million years. So we're going to skip to our last problem here. Alright, so this is the last problem we actually covered in class, since I'm making this in reverse order than how I make most of my videos. So what you see here is that first off, when you look at both these denominators, you're like, I don't know if my denominators are the same. Do they have any factors in the same? I don't know. So then what do we need to do first? First thing we have to do is factor both denominators just so that we know the factors of each denominator. So we're going to get 3x minus 1 over x plus 3 times x minus 1 minus x plus 4 over x plus 3 times x minus 3. Okay? So now at this point in time, we notice that this denominator is missing a factor that this denominator has. What factor does the left denominator need that the right denominator has? Hopefully you're like, oh, clearly it's an x minus 3. So just as we did with the fraction early on, we're going to multiply by x minus 3 over x minus 3. What denominator is this piece missing? What factor is this denominator missing? That's right, it's missing an x minus 1. So we're going to say times x minus 1 over x minus 1. Okay? So then we're going to multiply our numerators. So we're going to do first times first, first times second, second times first, second times second. So x times 3x is 3x squared. X times negative 1 is negative x. Negative 3 times 3x is negative 9x. Negative 3 times negative 1 is a positive 3. All over all three of these pieces. So that's the x minus 3 piece, the x plus 3, and the x minus 1. Minus, we're going to multiply these numerators. X times x, that's going to give me x squared. X times negative 1, that's going to give me negative x. 4 times x, that's going to give me plus 4x. And 4 times negative 1, which is negative 4. Over x plus 3 times x minus 3 times x minus 1. Alright, now that we have the same denominator, I can put all of this over that denominator, and I can combine my numerators. Okay? So I can combine my numerators. So I'm going to put all of this numerator. Now, I'm going to go ahead and combine these right here. That's negative 10x, and that's 3x. Okay? So I'm going to get 3x squared minus 10x plus 3. Now pay close attention to this. This isn't hard, but something you should know. This negative is going to change the sign of every piece of this numerator. So this positive x squared is going to become a negative x squared. This positive 3x is going to become negative 3x. This negative 4 is going to become a positive 4. Now I put like terms together. I'm going to write over to this way again. I'll change colors. My final answer is going to be in green. 3x squared minus x squared, that gives me 2x squared. Negative 10x, negative 3x, that gives me negative 13x. Then 3 and 4, that gives me plus 7. Over all three of these things. X minus 3 times x plus 3 times x minus 1. Now, what you should really try to do is factor this numerator. This video is already kind of getting long, so I'm going to tell you that this numerator is not factorable. But you should try to factor it in the future and see if you can cancel anything else out. Okay? So, I know this video is a little bit on the longer side than some of my other videos, but I'm still going to take one more moment to address one more problem, just because I think it would be good. Alright, so let's look at this problem right here. This is going to be our last problem we're going to do in this video. And I'm going to do this problem kind of quick. So first thing we have to do, we realize that these denominators are not the same. So the first thing I'm going to do is factor this denominator to see what factors it might have or share with this denominator. So, this guy, factors to x minus 6 times x plus 4. Okay? So now you realize that this fraction does not have the factor in the denominator of x plus 4. So we're going to multiply this fraction by x plus 4 over x plus 4. Okay? So now we're going to make sure we do first times first, first times second, second times first, second times second. So that's going to give me x squared plus 4x, x squared plus 2x, and then plus 8, over, now I have this denominator of x plus 4 times x minus 6. Okay? Minus, I don't need to change anything about this side because it already had both factors. It already had the factor of x minus 6 that this other guy had. So it doesn't need any more factors. Okay? So now I'm just going to rewrite it. Okay? Now that the denominators are the same, I can make this one big fraction. Now, for the second time in this video, I'm going to put both these numerators, I'm going to combine them together while writing it out as one big fraction. So, x squared minus x squared. Those cancel each other out. 4x plus 2x, that's 6x. 6x minus 5x, that's just x. 8 minus 14, that is minus 6. Now what do you notice? Well, the numerator has a factor that the denominator has, so I can cancel it out. So then what am I left with? I am left with 1 over x plus 4. And that's my answer. Alright guys, I know this video kind of ran on the long side and I know my software was glitchy, but I do thank you guys for watching. If you have any questions, please reach out to me, whether you leave a comment, whether you send me a reminder, send me an email, alright? However you need to get in touch, please feel free to get in touch. Now, for all my students that told me to do this, make sure you hit subscribe and you ring that bell. And what was there a third thing I was supposed to say? I don't remember. Alright, subscribe, make sure you follow. I don't know all the lingo, but you know, it's lit. Alright? But generally guys, I hope you guys enjoyed this video. Please let me know if something doesn't make sense. Please let me know if I made any errors. I thank you guys for watching. Good luck.